Hello Gators, this is lesson 3.1, the chain rule. The chain rule has to do with taking derivatives of composite functions. We're taking a look at a function within a function. Let's avoid this by making this into a product. So we'll make this into a product and we'll find the derivative, which means you take the function, the first function, take the derivative of the second, plus the second function times the derivative of the first. And that ends up, these quantities are the same, so there's two of them. Let's go ahead and write that on there, and let's take a look at what we see here. So this is the answer that we just got. And I want you to notice that this function on the outside is a squaring function. And notice what the 2 did. The 2 came over here, and if we take 1 away, it's like there's a 1 power here, but we just didn't put it in. And notice that the inside function has not changed. We just did the power rule to the outside function. But there was this additional product that we had when we were pulling things together. And this right here is the answer, and it's actually also the derivative of the inside. This suggests what we're going to be learning today. And the derivative of a composite function is the derivative of the outside with respect to the inside, leave the inside alone, times the derivative of the inside. Let's say that one more time. When we use the chain rule, when we have a function inside of a function, in words, we differentiate the outside and evaluate it at the inside function. So g of x is left alone, then multiply by the derivative of the inside function. Let's go ahead and do an example. I like to use the idea of a Russian doll because it's something inside of something. I use this when I describe composite functions. The outside function is this 4th power function, and the inside function is this 3rd degree function right here. So you have to understand what the outside function and the inside function is. So let's go ahead and take the derivative. The derivative is, I'm going to use my power rule on this 4th power. I'm going to do it with respect to the inside, so don't change anything in the inside, to the 3rd power. So I've taken the derivative of the outside, and I want to times by the derivative of the inside. Okay, and I gotta go to the next step. So I rewrite this part right here, which is part of the answer. And now I want to take the derivative of the inside function, which is 9x squared minus 5. And we're done. We have found the derivative. Let's do it again. The outside function is a sine, and the inside function is this power function to the 1st power. All right, so I'm going to take the derivative. And the derivative of the outside function is cosine with respect to the inside, don't leave the inside alone, times the derivative of the inside function. And the inside function is going to be a 3. I like to put the 3 in front of the trig function. It just looks cleaner instead of putting it in the rear. All right, so it's important that you understand outside and inside. So for this quantity, the outside is the sine, and the inside is the squaring function. Here, the outside is the square root, and the inside is natural log. The outside is the cosine function, the inside is the sine function, but inside the sine function is also a 5x function, so we have 2 insides. So the derivative of composite function is the derivative of the outside with respect to the inside times the derivative of the inside. All right, let's go ahead and give you an opportunity to do number 1. Stop the screencast and see if you can find number 1. And here is the answer. So take the derivative of the outside, leave with respect to the inside, leave the inside alone, times the derivative of the inside. And I just clean things up here. Before you start number 2, I want you to rewrite it as a power function. So write it to the 1/2 power. Go ahead and stop the screencast and see if you can do the problem. And here's the answer. Notice I had a -1 power times the derivative of the inside. Now whenever I have a negative power, I like to bring it down into the denominator so that it's no longer negative, and that is now a square root, and the derivative of this is 4. Did a little cleaning up and got that answer. Okay, let's see if we can do the chain rule when we're given values in a table. So the outside function is the squaring function and the inside is the g of x. So I'm going to find the derivative, and so I'm going to take the derivative of the outside, which is a power, with respect to the inside, leave the inside alone, times the derivative of the inside. I really didn't have to put to the 1 power. So this is 2 times g of x times, and then this is just g prime of x. I'd like to find the value at 4. So this will be 2 g of 4 times g prime of 4. So g of 4, here's 4, and g of 4 will be the number 3. And g prime of 4 will be -2, and so the answer will be -12. Okay, so the chain rule in function form. Now this is FOG, which is also written as f of g of x, and here's what I've been showing you all along. We can also use the Leibniz notation, where we take the derivative of y with respect to the inside, which is a u function, and then take the derivative of the inside with respect to x. So we can write it in this form as well. Let's take a look at one last example in which we have 2 insides. So I'm going to take g prime of t, and I'm going to take the derivative of the outside, which is secant squared of 5 minus sine of 2t, and then I need to take the derivative of the inside function, which is 5 minus sine of 2t. So now I have secant squared of 5 minus sine of 2t times, now the derivative of 5 is 0, so I don't have to worry about that. And then sine is my next function. This will be minus cosine, and there's an inside function 2t. So I have to worry about taking the derivative of that inside function. So now this answer is secant squared of 5 minus sine of 2t times negative cosine of 2t times 2. And I'm going to clean this up. I like to write the negative and the 2 in the front. I think I'll even put the cosine there, and then times it by the secant squared of 5 minus sine 2t. Okay, and that's the end.